All right. Welcome back. Another round of service mesh. All right, so my name is, just starting my timer, sorry. I'm going to be talking about the service mesh data plane. And I know we've had a lot of really good talks earlier. I'm going to focus more on the individual components that are used to run a service mesh, that are in the request path, and some of the different architectures and patterns that.
Your zipper is struggling with that.
Here, let's put it on the shirt. Is that better?
Thank you.
All right. Is that better? Okay. Okay, let's get going. Time is short. So my name is Christian. I'm a field CTO at a startup called Solo.io. At Solo, we build tools and technology to help people be successful with service mesh. I've been contributing to open source projects for probably the last 10 years now. I got involved in the Istio project a couple years ago. And I've been very interested in working with customers and adopters of service mesh technology, both in my time at Solo and before that when I was at Red Hat. I've written a book on Istio, and I'm writing another one right now. Manning sent me an email yesterday saying that coincidentally my Istio in Action book will be discounted for today and tomorrow, so I put the code up there for you. And if you're looking for holiday gifts for your loved ones, there's nothing like a deeply discounted point-in-time technology book, digital version, because it's not done yet. I also recommend these books on the same topic. The first one from the folks at Buoyant, I think it was written about a year ago. It's really excellent about service mesh in general. Lynn and Dan wrote a book, or actually they wrote a book, it will be soon available, I believe, called Istio Explained. And then Zach and Lee just recently published their book, Istio Up and Running. So huge congratulations to them. So again, Solo, where I work, we build tools like API gateways and debuggers and various tools to make service mesh successful. We will be announcing a few more things today and throughout the week. Come check us out at the booth. Whenever I start talking about service mesh, I like to point out a couple of the, because everybody talks about how awesome it is and all the problems you can solve with it, and it is good and it is becoming better. But you have to first ask yourself, do you really need a service mesh? And the answer may not be yes, depending on where you are in your adoption of these various pieces of technology, the application architectures you are targeting. You have to ask yourself, do you have a problem where you have a mix of languages and frameworks that you're deploying into cloud native technology, cloud platforms like a Kubernetes or whatever compute instances where the instances are ephemeral and could be auto-scaled, could be failing at any time. Do you have that problem? If not, then service mesh is not right for you right now. Have you mastered your existing technology stack? Service meshes are complicated. Have you mastered Kubernetes and all of the CI/CD tooling and so forth to get your applications out quicker, right? That's the whole point, is to make changes to your applications independent from one another and get them out quicker. If you haven't mastered those pieces of your technology stack, introducing service mesh is going to get you into a world of hurt. And actually, Tim Hawken just gave a presentation, I think a couple days ago, that showed how using something like Kubernetes can get you part of the way there. There are some primitives in Kubernetes, like the Kubernetes service, the Kubernetes kube proxy, that can give you certain levels of load balancing and service discovery and so forth, and leverage those to the fullest capacity before you start introducing new complicated technology. Some of the challenges that we see with our customers and with folks in the community adopting service mesh There's various lists of questions and concerns that they have, like which one do you pick? There's a new one introduced every day. How do you deploy this service mesh so that it's transparent to the rest of the applications? Sometimes that's the intention, but it doesn't actually happen like that. Now, we've seen people, and we've helped our customers get started by focusing in on operating the data plane and starting minimal, starting small in a crawl, walk, run style approach to adopting this technology. But since the data plane components, and I'm assuming for the most part that people understand the difference between the data plane and the control plane. I think we've talked a lot about service mesh over the years. I think that point's been hammered home. But with the data plane being on the request path, you need to be able to debug it when things go wrong. You need to be able to operate it. And starting off with 1,000 of them is going to be less successful than starting off with one or a few of them. And so we say get started, maybe put one at the edge, maybe put one as a gateway somewhere in your architecture, and start getting benefit from it today. Start to learn how to debug it and operate it and get telemetry and whatever other value out of it that you can. So in that vein, the data plane matters quite a bit. Unfortunately, there is confusion in the data plane these days. There are various parts of your application networking abstraction, which is what we're trying to do with the service mesh, that seem to conflict or they seem to overlap in some ways. So the distinction between north and south traffic that's coming into your cluster, into your boundary, versus the traffic that's happening on east-west. All right, so there's some overlap. They're both going to be doing traffic routing. They're both going to be doing maybe some kind of rate limiting, probably circuit breaking. But there are different concerns at the edge that you might use an edge gateway for or ingress gateway for that the east-west might not have to solve. Things like OAuth. Things like I know we've met with a lot of customers that have their very custom security signatures and handshakes that they have to do to stay backward compatible with their existing applications and so forth. Which sidecar do you pick? Envoy is a very popular open source project, but there are existing ones that have been out on the market for a long time. There are, for example, in Linkerd, very purpose-built and very specifically built for service mesh use cases. So which one do you pick? And then ultimately, a lot of the genesis for service mesh in a cloud environment comes from the implementations that we saw baked into different libraries and different frameworks. So things like Finagle at Twitter or Netflix OSS from Netflix, those were libraries that are actually baked into the application itself. Is there still room for those types of optimizations? And so the title of the talk here, the truth about the service mesh data plane, is going to dive into the various optimizations that you might make at the data plane layer and when to use which one and when maybe to avoid it. So the first thing to point out, I think, is we gotta, when we start to adopt this new technology, we don't want to just do it for new technology's sake, right? We want to have an end goal in mind and a reason to do it. And we should probably start measuring against that end goal at some point. But the point of the service mesh is to give you an API into your application network. Because just like William said earlier today, the service mesh enables other things on top of it, right? The service mesh should be boring. What we want is the things that we can enable on top of it. Now, how that API gets implemented, today, when we talk about a service mesh, we typically see that as sidecar proxies deployed next to each of our application instances, and it's a fairly common and consistent pattern across any of the service mesh implementations. But I think we should be looking at that abstraction, that network abstraction on which we can build, that implementation of the data plane as a spectrum, where Maybe we start off with something like sidecars, and we deploy that next to our applications where we can. But that for specific and maybe niche use cases, we might need to optimize in one direction or the other. All right, so you might want to implement some of this code, some of this networking logic in your application where maybe performance is a significant concern and you can't take the extra hops or whatever it is. All right, or on the other side, where it's too expensive to run a sidecar. And you might want to leverage shared resources in a shared gateway in some fashion. And so the data plane, how the Service Mesh API gets implemented is a spectrum, and you can opt to pick the right approach depending on the situation that you have. So when might you want to implement some of the networking abstractions in your code, like a finagle, like a Linkerd, or Netflix OSS. When performance is paramount or you cannot deploy a sidecar into your particular infrastructure, either for resource constraints or the operating system doesn't support it or whatever. I've been working in enterprise for quite a long time, and I know that whatever niche situation you might think doesn't exist, it exists. Or you might need fine-grained, super fine-grained circuit breaking that maybe your particular service mesh of choice doesn't offer. We might want to put some of those optimizations in the code. Now, you might want to watch out for, if you go down this path, getting down that slippery slope of needing to do this for every single language and every single framework that you might have. This is exactly why we started going toward a service mesh with the out-of-process sidecar deployment in the first place, is that operating that consistently is very difficult. Now, there is opportunity in service mesh land to make this a realization, make this pattern a realization without forcing too much of the implementation into the client libraries. So for example, HashiCorp Console, when they announced about a year and a half ago or so, they gave option to use a sidecar proxy, but they also gave an option to leverage specific library code. So they offer Golang extensions to their service mesh. So you can, inside your application, use the library itself, the client-side or server-side library itself, and not have to deal with the administration of sidecars and potential latency and overhead incurring. You just do it right into the code itself. The library that you adopt talks to the control plane and pulls down the various information that it needs and it implements it directly in the application. Now, implementing these various functions like load balancing and service discovery and circuit breaking and distributed tracing and so forth consistently across a bunch of languages, a bunch of different frameworks, and keeping it patched and keeping it updated with however tightly integrated and tightly tangled it is into your application code, that can be quite an undertaking. Which is why the idiomatic deployment of a service mesh today is with this out-of-process sidecar. And so what we can do is implement those pieces of functionality in a particular proxy through which the application talks, deploy it with the application, and get consistent behavior across languages and across frameworks. Now, something to watch out for in this case is deploying this proxy technology without understanding the data plane. So I pointed this out earlier, but I have actually talked with people who said, they're deploying Istio and they're interested in Istio, but what's Envoy? I've never heard of that, right? You need to understand the sharp edges and the characteristics of your data plane. We've talked with people who love the idea of the service mesh and deployed it. It's supposed to be transparent to the application, and it wasn't exactly transparent to the application. Things started breaking. One pretty well-known example is when the application starts to come up, it tries to make a call to a database or to another service, but the proxy hasn't loaded yet. And so the application can't make that connection, starts to fail, and wasn't built for retrying in the first place, so that loop continues to happen. And so just beware that when you start to adopt this technology that there's potential for leaky abstractions. Linkerd and almost all of the other service meshes, they implement this pattern. As I mentioned before, Linkerd implemented a very specific proxy to do this, and it gets deployed, injected alongside the application, and when services talk to each other or talk out of the cluster, they're talking through these proxies where we can apply things like the resilience pieces, timeouts, retry, circuit breaking. We can apply security and policy and RBAC. We can collect very consistent telemetry, how many, the call rate and failure rate and so forth. Now, another approach that we've been experiencing in the wild and have found it to be quite successful is this idea, especially when you're starting out, is deploying a gateway for a specific subset of applications. So each subset ends up with its own gateway, and then the applications talk through that. There are fewer of these sidecars deployed to give a chance for the application teams to, again, familiarize themselves with the proxy and operate it and so forth. It gives some of these subset of applications a single point of entry instead of just everybody talking to everybody. They like that structure in their application architecture. And also it gives a decoupling point between the subset of applications that might be implemented, let's say, with gRPC, but exposed outward, those, the clients outside of that boundary might want to use HTTP or something. So there's some decoupling as well at that boundary. Of course, this can get into the problem if you overdo it with additional hops, which may or may not affect latency and other resource usage. It's likely that the last mile to the service from the proxy could be insecure, depending on the rest of your security story and how services communicate. And of course, whenever you're sharing resources, you may find the possibility of contention and lack of isolation. Now, Istio is a service mesh, as you probably know, that supports both the sidecar proxy deployment as well as the shared gateway option. Istio has an Istio ingress gateway that is meant to be deployed at the edge and allow traffic into the cluster, but more generically has the gateway resource and the virtual service resources to allow you to have gateways run inside of the mesh as well. We have a lot of experience running our API gateway Glue in this exact fashion. Glue gives a more of an API gateway feel to this decoupling, where you can not only mediate protocol, but you can also translate maybe message. You might need to do some message transformation. You might want to do some very sophisticated and backward compatible security plugins and so forth. But this shared gateway and domain boundary gateway is something that we've had a lot of success with. And then lastly, implementing at the other side of the extreme, implementing these concerns in a proxy as a centralized gateway. I'm sure this is a common pattern, or at least I've seen it at quite a few enterprises, where you take a big maybe API management vendor and you stick it right in the middle and everybody talks to everything through that. That has some challenges around conflicting workflows and synchronization. Everybody has to get on the same page. Of course, you're sharing resources, so you have to watch out for isolation. But when you're just starting out, this is a perfectly valid way of doing it. You can have a single point of ingress and control everything from that. But as you start to grow, add additional workloads and additional teams and so forth, looking, or at least putting yourself in a position to decentralize is optimal. What time did I start? 20 minutes, okay. Now, along this spectrum, whether you're deploying in your application code or as a sidecar proxy or as a shared domain gateways or whatever it is, ideally you want to have the configuration be consistent, right? Because the service mesh provides this API to drive the configuration. And what you want is for that to propagate correctly down into the data plane, regardless of how that's implemented. And at the CNCF, I think it's Lyft and Google, and I think Amazon and Microsoft might be contributing as well. They've started a working group to try to address this, to try to build a unified API for the data plane that you can have plugins for various types of data plane implementations. And actually on the next slide, there's more information if you want to follow along. I think it kind of got kicked off back in August and is, there's been a slowdown recently, but I think it'll pick up starting in 2020 to further prove out and define this API. Now, what I've talked about so far, a few different patterns, a few different, some of the service meshes implement it, some of them don't. But things are going to start to heat up even more. There's this technology called WebAssembly. I'm just curious if you could show by hands how many people have heard of WebAssembly. Just kind of kidding. Oh, awesome. OK, perfect. WebAssembly is a way to dynamically load and run code in a sandboxed and secure environment. So you can inject this into, it was originated in the web browser community to be able to optimize certain parts of the JavaScript applications and run that code in a secure way without compromising the web browser. But the interesting point is that you can write the code for WebAssembly in multiple different programming languages. The WebAssembly toolchain will compile it into an intermediate representation and then ultimately compile it down to the platform when it runs. But you can write, you can write it in C and C++ and Rust. And I think there's some limited and forthcoming support for garbage collected languages as well. And so that starts to become kind of interesting when you talk about plugging this type of runtime into a network proxy like Envoy. So Envoy is written in C++. Envoy is, I think, has been awesome in that it's very extensible. A lot of different parts of the API where you can write extensions and filters and other plugins for connecting to various back-end telemetry systems, for writing HTTP filters to do things like policy enforcement and so forth. But now if we have this ability to write it in multiple different types of programming languages and not have to compile it and statically link it into the Envoy binary, and we can load it at runtime, and maybe even mix and match the various plugins that we might want to write with WebAssembly. Things become really interesting, and this spectrum between what is in your code and what is in a proxy, whether it's shared or sidecar, now becomes even more blurry. We just announced Glue 1.0. Glue is an API gateway built on Envoy proxy. And with the 1.0 announcement, we are supporting WebAssembly in beta. Now, Envoy also happens to be the underlying proxy technology for a lot of different service meshes. So what I'm going to show you today in the demo is how we can write some WebAssembly code, inject it into, in this case, Glue, to modify the behavior of the proxy, but just think outside the box a little bit. This feature set will be coming to Envoy soon and ultimately to the different service meshes. I think at the Istio meetup later tonight, I think Louis will give a roadmap update on when that will be coming. But let's take a look real quick at a demo. So this is a live demo. Please cross your fingers for me. I have a script to help with the typing, at least some of the typing parts, but it is a live demo. This is not a video. Might have to switch to the video if it dies. But so the first thing we're going to do is we're going to create a route in Glue's routing table to allow external traffic to call in and talk to our cluster. So we just created the route. Now we're going to get it, see it's been accepted. It looks like it has, so things should be good. Now what we're going to do is curl the proxy. And on the other side of the proxy is a very simple echo service. And we see the response was good. We got an echo response from based on what I sent in. What we're going to do in this demo is we're going to write some C++ code that will dynamically inject into Envoy here. And what we're going to do is very simple. We're just going to add some headers just so you can get an idea of that we can dynamically change the proxy's behavior. So to do that, we're going to open up our source code. And I apologize, I don't think I can't seem to make it. What if I zoom in? Does it zoom in over there? Yeah. Oh, perfect. So what we have is our C++ code. I kind of got it started. I'm not going to sit up here and try to type all this stuff out. But what we're going to do is on the response headers section of the Envoy filter and eventually running in WebAssembly here, we want to override that and add some new headers that get returned in the response. So we're going to grab that. We'll grab that. Come down here. Let's add that. Let's make this a proper C++ method. We'll return a proper status. And then we'll add response header. We'll say that this is the KubeCon header, and we'll say, just give it a name. Now, this is written in C++. We're going to need to use a tool chain to compile this down into WebAssembly. And to do that, we've built a helper project to kind of help you get started that uses Bazel to do the build, and it pulls in the mscripten tool chain and does and all that stuff. And we should be able to cross our fingers, build the WebAssembly module right here. And if Bazel cooperates, all right, so far so good. The next thing that we're going to do is, so we built the WebAssembly module to inject it into our proxy. What we want to do is share it in a shared registry somewhere. And so what we're going to do is we're going to push this WebAssembly module up into a shared storage, into a Docker registry running on Google in this case. And cross our fingers for that one as well. And that looks like it's all right. Okay, for business. Now, the next thing we're going to do is, so now that we have our WebAssembly module up in our registry, we need to configure Glue or configure Envoy under the covers to load this WebAssembly module. And so to do that, we'll take a look at the configuration for our listeners. And we can see here I'm going to configure this to load the WebAssembly module that I just created and pushed to GCR. And we can verify that by coming here, refresh. It is here in GCR, it was updated just now. And we're going to apply this listener, this gateway, to Glue, to Envoy. And from there, Glue will go will dynamically pull it down and load it into Envoy, so that when we make the call, a curl call here, we should see our new headers added. No, damn it. What happened? One second. Damn it. It's running fine. I don't know. Did I mistype something? That's what I get for trying to. No? Fuck. I don't know. I didn't put return in there, oh my goodness. Thank you, whoever said that. I got 10 more seconds. There we go. All right. All right. I have completely run out of time. Come to our booth. Check out Idit's talk at 2:20. I'm doing a workshop on Service Mesh for the developer workflow, and Michelle is up next to talk about SMI. Thank you.